Hi everyone. Design consideration for the bumper B on the 5,000 kilogram train wagon require use of a nonlinear spring having the load deflection characteristic shown in the figure. Um, the wagon is traveling at 4 meter per second when it strikes a rigid stop. What is the value of K that the maximum deflection of the spring is limited to 0.2 meter? So this is a question that is the spring at B here, and we need to find out the value for K as I said. This is a work energy question, work energy related question. So you know that from by formula in chapter 14.1 or from the Hippler book of dynamic mechanics of structure, or I can't remember. Anyway, T1 plus the work of T1 to 2 is equal to T2. That is the kinetic energy, and this is the work. So kinetic is half of mv squared, and this u, which is the work, it is F times dr, force times the distance, or because here it is for the spring, so it is sort of like k times k ds or ks ds. So to solve this question, um, the wagon has got the initial, like the kinetic energy, which is m, the that is 5,000. Let me just write down the formula. So it is half mv squared minus the integral, that's for the work, which is ks squared ds, is equal to T2. And T2 in the secondary stage, it is 0 because there is no velocity in the secondary stage, or the wagon stopped, so that has gone to 0. And why is that negative? Because the work acts in the opposite direction. So the wagon is coming this way, but the work acts in the opposite direction. So it is half m is 5,000. The initial velocity is 4 meter per second squared minus the integral of k s to ds. The bound of integration, we want to have it for ROM as it says 0.2, so from 0 to 0.2 meter ds is equal to 0. So what do we need? We need the value for this k. So half of this is 16, 8, so that is 40,000 minus, I will do this integral for you, that k, we need to integrate it with respect to s, so k has to be treated as a constant. We take it out of the integral, so between 0 to 0.2 s squared ds. So easily, you know, the integral of s squared ds is s cubed over 3, and the bound of this integration, I'll just write it here, is between 0 to 0.2. I just sub in the value 0.2 over 3, and that is cubed So from here, this value is something is 0.002666, and it's repeated. And if I'm just going to get the value for k, I need to write it 40,000 is equal to k times that 0.002666. If I just rearrange it for k, the k value would be 10 to the 6 Newton per meter square, or you can say 15 mega Newton per meter square.